Hello everyone. Assalamualaikum warahmatullahi wabarakatuh, and a very good morning. Sorry, I got something to know. Okay, have you registered your attendance? So please do. So I'm not gonna give you the link on what do you call it on Zoom because you can communicate through YouTube. Okay, good morning everyone. Okay, so today basically I will show to you how to make the introduction of the course. Okay, last round we got to know each other. So this is can you see the slide? Okay. All right. So okay, what is statistic? Okay, there are basically two types of statistic. So with descriptive statistic, you are simply describing what the data shows. I mean to say that we are describing the data that we have. And next one is with differential statistic, you are trying to reach conclusion that extend beyond the immediate data alone. For instance, we use differential statistic to try to infer from the sample data with what the population might think, or we use differential statistic to make judgment of the probability that an observed difference between groups is a dependable one or one that might have happened by chance in this study. Okay, so at the end of this lecture, students should be able to identify data analysis via descriptive and differential statistic. Next one is to represent data descriptively using graphical technique, and last one is to represent data descriptively by numerical calculation. Okay, what is descriptive statistic? So it is a graphical technique basically. So we have so many graph available, right? If let's say you go through the Excel, you can understand from that. So it can be anything. And it is used to describe the basic features of the data in a study. Okay, so basically, there's so many graph available. So basically, not all graph is suitable for such set of data. So you have to know which what kind of graph is suitable for that kind of data, and it provides simple summaries about the sample and the measures, and together with a simple graphic analysis, they form the basis of virtually every quantitative analysis of data. Okay. Next one is there are basically two types of data here, which is quantitative data and qualitative data. So what is quantitative data? Quantitative data are made with instruments such as rulers, balances, graduated cylinders, beakers, and thermometers, and these results are measurable because which can be identified by numbers. At the meantime, for qualitative data, it uses the senses to observe the result. So, if you can relate, or maybe you can understand by this, the only difference between quantitative and qualitative is For the quantitative, it is measurable, so it can be a number, any kind of number. So it can be any unit like temperature, the degrees Celsius, the milliliter, and everything that involves the numbers. And the example of the qualitative versus quantitative data is qualitative data is descriptive information because it describes something, and quantitative data, it is numerical information. So it is crystal clear, right? So basically, you have to really understand this because I'm expecting you to incorporate or embed this data, especially the qualitative and quantitative data for your final project, which we will start by this week. So quantitative data can be discrete or continuous, and discrete data can only take certain values like whole numbers only, not. And the discrete data is counted, and the continuous data can take any value within a range that we have identified, and the continuous data is also measured. Okay, how to do the data collection? So the simplest way of data collection is through direct observation, but it is of course very tedious. And the convenient way of data collection is by using the Google form in this text. And the scientific way of data collection is through experimental studies. Alright, so basically data collection. This is for data collection for quantitative data, yeah. But for qualitative data, usually they have the in-depth interview, or they will have the session, the closed session with several people, and then from that they will transcribe, or maybe you have to transcribe uh, the conversation into data. Or census of sample. Census is when we collect data for every member of the group, like the whole population. And the sample is when we collect data for the selected members of the group. And the census is accurate but difficult to retrieve. A sample may be accurate but good enough and more practical. So what is the distributed population example? So if you can see here that this is the whole population here, 1, 2, 3, 4 until 12, and this is the sample. So basically the sample is, we don't take every each item in the population, so we just take a sample out of it to represent the whole population. Okay, so this is also the clear, a clearer example. So I mean to say that from, for example, right, the population in Selangor, this is out of it, and then we just take one in Shah Alam, one in Ampang, one in Petaling Jaya, one in Subang, and one in Kuala Selangor. So it makes up the sample or the population in Selangor. And what is it between population and sample? Population is the measurable quality is called a parameter, and the population is a complete set, and reports are a true representation of opinion, and it contains all members of a specified group. In the meantime, sample is the measurable quality is called a statistic, and the sample is subset of the population, and reports have a margin of error and confidence interval, and it is subset that represent the entire population. So basically, it's not really important. You just have to know that a sample is the subset of the population. And what are sampling techniques? So basically, there are two types of sampling techniques. So the first one is non-probability or non-statistical sampling, which is judgment, voluntary, and convenience. And next one is statistical sampling techniques, which are simple random, systematic, stratified, and cluster. So these are the example for the statistical sampling, which is for simple random. So you just pick anything, any sample in random order. So it can be this one, this one, this one. You just pick in random. But actually, for the random order, it takes you to have a lot of number of sample. So that's the one of the weakness. So for the systematic sample, so you just choose this one accordingly, according to the systematic one. So I'm say that you have to choose this one, this one, this one, this one, this one, this one. Okay. And for the stratified, so you make it into the strata, and then you choose the sample. And for the cluster, you divide them into the cluster. For example, maybe according to the age, and then you just pick the cluster sample. For graphical data representation, one of it is bar graph, which is the graphical display of data using bars of different heights, and histogram is the graphical display of number of ranges uses bar or different heights, and frequency histogram, special histogram that uses vertical columns to show frequencies and how many times each score occurs, and line graph, a graph that shows information that is connected in some ways, such as change over time. And pie chart is a special chart that uses pie slices to show relative sizes of data, and stem and leaf plots, a special data table where each data is split into stem, the first digit, and the leaf is usually the last digit, and scatter plot, the XY plot that show the relationship between two sets of data, and line plot, beneficial in real-time surveying or data collection. So basically, you have to know the difference so that you can know which graphical data to report your final journal in your final journal report. Okay, in your comment section in the YouTube link, I want you to give one example of the experiment by using quantitative data. So don't forget to mention your name and your ID, because I will take note of it. Okay, one more, give one example of experiment by using the qualitative data. Okay, I give you 5 minutes.